morning, good evening, depending wherever you are watching me on the blog. Today we are just going to continue with our normal series for the volumetric analysis, and in as far as titration is concerned. So we are just going to do a practical here for a demonstration practical here for titration. So now within me here, we shall just go to the procedure direct. That is titration practical 8, and I'm just going to take you through the procedure so that you can be able now to embark on the practical itself. So you are required to, with 0.2 molar nitric acid C10, it is labeled C10, solution C10, and sodium carbonate D11. You are required to determine the concentration of sodium carbonate in grams per liter. And then the procedure, it is as follows. Fill the burette with solution C10 using the pipette. Using the pipette filler, pipette 25 cubic centimeters of solution D11 into a clean conical flask. Add 2 to 3 drops of methyl indicator. Add 2 to 3 drops of methyl orange indicator. 4. Titrate solution D11 with solution C10 from the burette. Record the results in the table below. So now we are just going to do the titration here. Now I have the solutions with me here. We have sodium carbonate here, which is sodium carbonate here, which is D11. My D11 is here, and then also I have the nitric acid, which is C10, which is here. So now I'm supposed to fill the burette. We have been instructed to fill the burette with C10, which is the nitric acid. So I'm just going to do so. But before I do it, I'm supposed also to rinse the burette with a liquid solution, so that in case of any contaminations of the burette, for example with another acid or with some dirt or anything that might interfere with the number of moles, I'm supposed to rinse the burette with the solution. Then I drain it in the sink like that. Then I return the burette onto the retort stand, and make sure that you put the retort stand, you return it firmly on the retort stand carefully like that. After you have done that, you close the tap of the burette so that when you will be pouring the solution, it does not drain away. So we are filling C11, C10, which is dilute nitric acid. So after we have done that, then we make sure we start at the mark 0. So I'm reducing it up to the 0 mark. So that is the 0 mark now. After you have done that, then I'm supposed now to pipette 25 cubic centimeters of sodium carbonate. So I'm going to pipette 25 cubic centimeters of sodium carbonate into the clean conical flask. We are just following that procedure. Make sure you are at the mark, because we have some mark where the solution is supposed to reach on the pipette. So this is 25 cubic centimeters of D11. So now I'm putting it into a very clean conical flask, like that. You make sure all the solution enters into the conical flask before you start the fast titration. like that. Make sure the last drop enters into the conical flask. Then from there, we have been instructed to put 2 to 3 drops of methyl orange indicator. So I'm putting 1, 2, 3. So now, as you can see, the solution now appears orange. But it's supposed to change from orange to pink. So I'm putting it under the burette so that I can start now titrating. So you just start opening the tap of the burette slowly by slowly as you shake. Make sure all the drops drop into the burette, into the conical flask. Our expected color is supposed to be pink. So you just do it slowly as you observe the color change. Very slowly like that. So our expected color change is supposed to be pink. We just do like that. Now, wow, the color has changed. You can see the color has changed into pink. Very nice color. So now we come here. We go back to our burette reading. So we just find out how much is it. It has changed to Mark 15. So we come here and record. Our initial burette reading was 0.0. Now the final burette reading is 15.0. So now we refill the burette, and then we go to the second titration column. So we are still refilling the burette with solution C10. So most of the time we usually put the filter funnel there, but currently you can, if you are just very carefully, you can just use it like that. Just make sure that it does not splash away. But if you are not very careful, you are just supposed to use the filter funnel. So we are just trying to get to start at the 0.0 at the low meniscus, and also you are supposed to look at the meniscus so that you be accurate with your results. So this one, I'm just going to pour it away. You can just even decide to pour it away, or you can just take a fresh conical flask and then you do the same. You pipette now solution D11, which is sodium carbonate. So we are just going also to use the pipette to do that. So you just drain it slowly like that. Just drain it slowly. Good. Now, this is 25 cubic centimeters of solution D11. Put it like that. Let me put it close so that you can see what is happening here. Like that. Like that. Then you make sure the last drops goes into the conical flask. Then after that, we are also going to put the indicator, which is methyl orange indicator. It's here. Put 1, 2, 3 drops of the indicator. So we are starting at the 0 meniscus. the 0 mark. So now, since we know that our color change will come from at around 13, 14, 15, then you are not supposed to waste a lot of time titrating. So you just open this tap, but very carefully as you shake, so that the solution distributes itself uniformly, mixes itself uniformly in the conical flask with the two solutions just mixes themselves in the conical flask. So you just do it very fast like that. It has changed. Wow, it has changed. Now, it has changed at 14.9. So you can see even the color is pink itself. It has changed at 14.9. So we just come onto our table here and let's write 14.9. Then 00 as usual, our usual burette reading. Initial burette reading. So I'm just going to drain this. Then from there, we are also going now to the third titration. So we are on in this column. So we are going to titrate 25 cubic centimeters of solution D11. So you start now removing excess solution from the pipette until when you reach the mark, the required mark. That's, yes, like that. So I'm putting 25 cubic centimeters. Let me just use this one because it's the one that looks a little bit clean. Good. Now, we are done with that. So, we, as usual, we are supposed to put the indicator. So, we are putting 1, 2, 3. Then we put it aside because we are also supposed to fill the burette with the solution C10. So, I'm refilling the burette with the solution C10. So now I'm very accurate. I am at the 0 mark. So you just put the conical flask below the burette tap. Then you open the tap. As you shake like that, as you shake like that, like that, like that, like that, like that, like that, like that. Our expected color change is supposed to be pink, as you have been seeing in the first 2 titrations. Wow, the color has changed. Almost. Wow, the color has changed. The color has changed to pink. As you can see, this is our third titration. So we come here and record. How much is it? 15. So we just come here and record 15.0. Then our edition was like that. So now, if you want to get the volume of the acid used in each column, we just subtract this from this. Then we get 15.0 15.0, and then here 14.9, then here 15.0. Most of the time, you can decide to take the first close values and then we omit this, or you can just even decide to take the average volume using each column. So we are going to write we have been told to determine the average volume of the solution C10 used. So average volume of solution C10 used is going to be is equals to first titer plus second. Let me just take first titer plus second titer. We are in this case we are just going to use these two columns, this one and this one. So first and third. First and third. It is allowed in the titration, and then we divide by 2. These are cubic centimeters. So here we are going to get 1530 divided by 2, which is going to be 15.0 cubic centimeters. This is our average volume of solution 10 used. So let us just go to the second question. We have been asked to determine the number of moles of nitric acid solution 10 used. To determine the number of moles. The number of moles in this case, number of moles. We have been told to determine the number of moles of nitric acid used, of nitric acid solution C10 used is equals to, number of moles is always equals to molarity times volume. So, in this case, we have been told nitric acid, the molarity of nitric acid is 0.2. So we come here, we substitute 0.2 times the volume here, which is 15 here. Then we multiply it by that. Because of the molarity it is always over 1,000. So we put these ones over 1,000 cubic centimeters. 1,000 cubic centimeters, which is going to give us, if you do the mathematics properly, you are going to get something like this. 0.03 moles. Then here we have been told to determine the number of moles of sodium carbonate solution used. Now in this case, we must write the equation first. So we are going to write like this. Let me just put this one aside so that you can be able to view properly. We have been told to determine the number of moles of sodium carbonate used. So we are going to write an equation like that. Plus sodium carbonate, this is nitric acid plus sodium carbonate. It's going to give us sodium. It's going to give us, this is sodium carbonate. Let me see. Like that. So after we have written that, it's going to give us sodium nitrate plus carbon dioxide plus water. This is liquid, this is aqueous, this is aqueous, this is also an aqueous, this is also an aqueous. So now we are supposed to ask ourselves, is this equation really balanced? If the answer is still no, then we are supposed to compare both the reactant sites and the product sites. If the atoms are properly balanced, atom by atom. For example, we are going to start with the hydrogen. Hydrogen, how many hydrogens are on the reactant side? 1. On this side, we have 2. So we are supposed to write here 2, so that we have 2 here and then 2 there. Then nitrogen. How many nitrogens do we have? 1, 2. On the reactant 2. On this side, we only have 1. So now, we write here 2. So that we can have both balanced. Because we have 2 nitrogens and also this, we have 2 nitrogens. How many oxygens do we have on the left-hand side? We have 6. This one times this is 6 plus this, which is 9. And on this side, we have this is 6 plus this 7, 8, 9. So oxygens are balanced. Sodiums, how many sodiums do we have? We have 2 sodiums, 2 sodiums. So it is balanced. Carbon dioxide, we have 1 carbon dioxide, carbon on this side, on the left-hand side, and then the product side, we also have 1 carbon. So that equation is balanced. Now we have been told to determine the number of moles of sodium carbonate solution in D11. Remember D11, it is the sodium carbonate. So the mole ratio here it is 2:1. And on this side we have found the number of moles. This is just the mole ratio, and then the volume we found here it is 15.0. This is the average volume. And on this side, we found it is what? 25 cubic centimeters. So now we are trying to calculate the number of moles that were present here in 25 cubic centimeters. So since the mole ratio it is 2:1, and the number of moles in the solution C10 it is 0.03. So we are just going to come here and do this. Take 1/2 times 0.003, which is going to give us, if you do your mathematics very properly, this one 1, then this one 0.0015. If I'm not very wrong, that is it. 0.0015 moles. Higher. D. Determine the molarity of sodium carbonate solution D11. Now we have been told to determine the molarity of sodium carbonate D11. Molarity of sodium carbonate. So we are just supposed to ask ourselves, if 25 cubic centimeters can be able to give us 0.0015 moles, what about in 1,000? So in this case, we are just going to cross multiply this times this over that. So we are going to take 1,000 times 0.0015 divided by 25. All this is the molarity, which is going to give us, if you can do your calculations properly, you will get something to do with the 0.06 m. 0.06 m. If I'm not very wrong, according to the calculations here, if you can just do your calculations properly, you will find something of that nature. Last but not least,